Hello, and welcome to Owning and Operating an Irrigation System, Part 1. I'm Jim Mull. I'm the Florida Friendly Landscape Program Manager here in Pasco County. So you know a little bit more about me. I'm originally from Milwaukee, Wisconsin, and I got my degree in horticulture from the University of Wisconsin in Madison. Upon graduation, I literally said aloha to Wisconsin. I moved to the island of Kauai and took an internship at a botanical garden, and then worked at a nursery on the island and was there for a little over a year and a half. And then I moved to the Philadelphia area for a couple of years, and then ultimately took a job at a place not terribly far from here, and you may have visited, called Bach Tower Gardens in Lake Wales, Florida. And I was there for a little over 7 years before I started in Extension in late 1999. I started in Extension as a horticulture agent in your county, Hernando County, and was there till 2013, and now have been here in Pasco County since 2013, and I'm pleased to be asked to teach you a little bit about irrigation, the things I've learned, the do's, the don'ts, the things that we take for granted, and how to maintain them, owning them, and some troubleshooting along the way. So what is normal rainfall in the state of Florida? Think about that for a moment. A lot of people have different thoughts to that, and it's kind of hard to think about it, but while most of our rainfall is going to occur between the months of June through September, and then the remainder of the year it can be kind of spotty, we usually kind of think about normal rainfall as somewhere about 50-55 inches. But here's a graph coming up in a second from Southwest Florida Water Management District, and it documents a little over or right around 100 years of weather data, and the mean rainfall for the district, which is 16 districts including Hernando County. And you can see over the 100 years the ups and downs of rainfall. Some years we're in a deficit. Look at starting in about the year 2000 or so, there was an extended period of drought, and then we had a couple of up years in till about 2008 or so, and then some down years, and it seesaws back and forth. But if you look at kind of a long term, you can see that the surplus years are seemingly fewer and not as great as they were before about 1961 or 2. And we see more deficit being longer and more frequent after about the 1960s. So our normal rainfall, or average, this is the normal rainfall I should say, is this up and down and back and forth. We average it out and we average about 50 to 55 inches. But in between some years we do have to irrigate. But does that mean we always have to irrigate routinely? Not necessarily, depending on our conditions of the time. So another question to think about for a moment. So why do we have these frequent droughts in the state of Florida? Think for a moment. Where are we located on the planet? Of course we're in Florida, but what latitude are we at? Let's look at a world map for a second. And as you can see, spot yourself where Florida is located. And if you go across heading east, and if you were to go to the African continent, you can see we're on the same latitude as those deserts of Africa. Keep going east and you're in the Middle East, and where we pump oil from Saudi Arabia and countries like that. And if you go around the world and get to the Baja California area, you would see that it is also at a latitude of the deserts of the northern hemisphere. So we're at the same latitude as all the deserts of the northern hemisphere. So why do we have 55 inches of rainfall? Well, if we look at Florida, we realize it's a peninsula sticking out between two very large bodies of water, the Gulf of Mexico to our west and the Atlantic Ocean to our east. It's the heating of the land and then the subsequent cooling of the air and the water condensing during our summer months that gives us the rainy season, and most of our rainfall, about 3/4 of it will fall during the summer months, with the rest of it falling kind of erratically in the winter months when fronts come through. And generally we have fairly consistently dry conditions sometime in March through to the rainy season beginning, which is sometime in June. This can vary from year to year though, however. I heard this said once, and I like to reiterate this in some way, shape, or form. Florida is a desert with a distinct rainy season. And I like that thought, because if you think about it, what kind of soil do we have in Florida? Most of us are dealing with sand. And all the deserts have, guess what kind of soil type? Sand. We just happen to have a rainy season that deserts don't enjoy. So, efficient irrigation. Put plants according to the water needs together in a zone. That sometimes doesn't happen very often in some of our landscapes, as they're usually designed as a cookie cutter from model home to model home. Well designed, installed, and maintained. I hate to say it, but many of us, our irrigation system went to the lowest bid. And how do you get to the lowest bid number? Usually that means cutting corners somehow, spacing out irrigation heads too far apart, using too small a pipe, or some other issues. Irrigation scheduling. A lot of us know water restrictions, knowing we can only water once a week if we're on potable water in our county. But the point is, do we always need to be watering that frequently? Notice how I said that, frequently. A lot of times people are over applying water, and they're watering just because they can on a certain day of the week, as mandated or required by our water management district. So let's look at irrigation a little more closely, and the various types of spray heads that we have or might see in our travels. The first one are the stationary or the pop-up spray heads. The one in the upper left-hand corner obviously has popped up, and it's spraying about 90 degrees of water in a fan. It doesn't move or turn in any way, shape, or form other than to pop up out of the ground from its casing. The upper right-hand picture you can see is 180 degrees of spray, so it's a half a circle that it's covering, usually used along the edge of a path or by the edge of the driveway or something like that. The lower picture are spray heads that are putting it out in a complete circle. So your pop-up stationary spray heads may do a quarter, half, 3/4, or a full circle or some variation thereof. But they don't move in any way, shape, or form. So they're constantly spraying water over the area in the pattern that they're designed. Went the wrong way, sorry about that. Rotors are usually spaced much further apart because they can spray quite a bit of distance. Typically they're spaced between 25 and 35 feet apart, depending on how far they're rated to spray out. They're usually used in very large areas, such as turf, as you can see in the picture here. Again, each of these heads is putting out a certain number of gallons per minute. So that head we see in the foreground may be putting out 5 gallons or 10 gallons each minute it is running. However, the precipitation rate of rotors is only approximately about a half an inch per hour. Again, that's a rule of thumb. Why is its precipitation rate so much less than a stationary spray head? Well, let's think about rotors for a second. They have to turn to cover that large area that they're spraying water onto. So it takes that rotor head maybe a minute or two to complete its full rotation or part of a rotation, depending on how it's adjusted. So rotor heads need generally a lot longer runtime to achieve 3/4 of an inch of precipitation. Their approximate runtime is between 1 and 1.5 hours. Now, as a Master Gardener trainee newbie, you may be thinking about your irrigation system right now and how you've adjusted it. I typically see people adjusting their time clocks to run each zone for the same amount of time, regardless of the spray head that they have in that particular zone. So a lot of times rotor zones can be underwatered because they're not running long enough, and spray head zones are running too long. Also, let's think about where a lot of times where the rotor heads are placed versus spray heads. Usually we see spray heads along the edges of the house, right behind the shrubbery. Most of our trees and shrubs are fairly drought tolerant once they're established. If you're watering those plant material more than 3/4 of an inch and you're doing it every week, eventually those plants may suffer. Conversely, if you have rotor heads and you're running them for only 20 minutes, let's say, maybe there are reasons you're having brown spots in your turf. Those areas may be getting underwatered. We'll talk more about calibration in another section of irrigation. Then there's a third type of irrigation that's becoming more and more common in our landscapes. In some cases here, like in Pasco County, it's required by law that you can only water so much with high volume irrigation as what I've discussed till just now, till the microirrigation. Microirrigation is kind of a very large, broad category for a number of different types of emitters that we commonly see. The inline drip tubing, which is the lower right-hand picture, drip emitters, which is the lower left-hand picture, micro sprays, which is the lower center picture, putting out the little fingers of water, and then we have bubblers. That's the upper right-hand picture. That's putting out appears to be a large spray volume. Bubblers are considered micro irrigation if it only puts out 30 gallons per hour or less. If it puts out more than 30 gallons per hour, it is considered high volume irrigation and would have to follow the restrictions of other high volume irrigation, which is typically once a week in our counties. Microirrigation currently, as of the time this was recorded, is not restricted in the District of Southwest Florida Water Management. That may change in the future. Now, what's the difference between high volume irrigation, the stationary pop-up heads and the rotor heads, is microirrigation heads, all that you see here, are rated in gallons per hour. So that lower left-hand picture, that drip emitter, that emitter where it's going drop, 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 is only maybe putting out 1 or 2 gallons each hour from that little orifice. Or the little finger sprays of the micro sprayer, putting the little fingers out in the middle lower picture, that may be putting out 2 gallons or 5 gallons per hour or something like that. The inline drip tubing, the lower right-hand picture, each of those wet areas of maybe a half a gallon is coming out per hour, or a gallon, or 5, or whatever, depending on the diameter of the hole. There are ratings on these. Again, the bubbler can vary, but if it's less than 30 gallons per hour, it is considered microirrigation. Let me give you a side note about bubblers. Why are they used? If you look at the left-hand side of the photograph in the upper right-hand picture, you can see there's some large plant material. Typically, this is either used on very large shrubs or typically on tree installations, as a lot of water needs to be directed directly to the root ball for establishing large plant material such as a tree. What are the advantages of microirrigation? They can save water when used properly, but again, they can be overused, or microirrigation can be overapplied. It delivers it much more closely to the root system, so there's less chance of loss due to evaporation into the atmosphere. Like all irrigation, it can be automated with a time clock, or even in some cases hooked up to a hose bib with a timer. It can be placed underground or under the mulch. Drip tubing is commonly put around nursery stock or shrubs in new installations, especially here in Pasco County, and then it's mulched over, keeping it out of sight. Soaker hoses can also be done this way, but soaker hoses aren't the best irrigation device here in Central Florida. Soaker hoses work by oozing water through the walls of the plastic piping. The problem with this is we have a lot of calcium in the water. Eventually those small pores get clogged up with calcium and soaker hoses will fail. There are disadvantages to microirrigation as well. It typically can be very high maintenance. Again, most of these orifices that emit the water are very small in diameter. They can be clogged up with debris from the irrigation water, depending on its supply source. It can also clog up with calcium, and that needs to be cleaned. If it's under the mulch, like a lot of things, when it's out of sight, it gets out of mind. And from my experience, inline drip tubing somehow magically attracts your shovel to it and you cut it. Sometimes people won't even tell you that they've done that, and you just have to discover it on your own. One of the big disadvantages of micro irrigation is its limited wetting in our sandy soils. I'm going to show a picture in a moment of that. But our sandy soils don't have a lot of water moving sideways from where the water is emitting. So it moves more or less downward in a small column. Here's what I'm trying to visualize for you. Here's some inline drip tubing, and you can see some young plants are planted right by the hole that's dripping out the water. And these appear to be some young vegetables. And you can see that they're planted right where the hole was. And they're getting water right by the root system. Not using a whole lot of water, getting it directly to the root ball, very efficient. But let's say I put a new shrub right in between those two rows of black poly pipe. How much water would that new shrub get if it were in the middle of that? You can see that there's so little lateral movement or sideways movement that a plant right between those rows would die very quickly of dehydration. This is a big problem with inline tubing, especially when it's mulched over and all this is hidden and out of sight and thus out of mind. I much prefer micro sprinklers or micro sprays in these situations for a few reasons. First of all, you can see the spray is coming out at about 3 or 4 feet in diameter. That can vary depending on the exact type of micro irrigation spray head that's installed. So it's wetting a larger area of the root system of these particular plants, which are impatiens, which, as we know, require quite a bit of water. This is a much better way of getting water to these plants than drip would be. You'd have to snake drip tubing around to reach each of those individual plants, which would be very difficult to do. But let's go back to some things we've learned so far about irrigation. This is micro irrigation. So each of those heads is rated in gallons per hour. So that 4-gram sprayer may be only putting out 2 gallons per hour. And hopefully if they're matched right, they're all putting out their same amount. So 2 gallons per hour isn't a lot. So a lot of people think, gee, that needs to run for many hours to get enough water to these plants. But the precipitation rate, let's go back to that and revisit it. Precipitation rate of most of our micro irrigation devices, except for the bubblers, is approximately 2 inches per hour that it runs. Now remember, each drip or spray may only be gallons per hour coming out, but its precipitation rate is a lot closer to those pop-up stationary spray heads that we first learned about, which was, what was that per hour again? That's correct, 2 inches per hour for stationary spray heads and for micro irrigation. A lot of people don't realize that micro irrigation puts out a fair amount of precipitation rate. They're just spaced much more closely. And here it is in the landscape, newly installed landscape with some junipers and apparently a weeping holly. And yeah, you can see the black little stakes that they're on, and they do come in other colors other than black. You can get them in green to blend in better. But let's say the poly hose that's connected to got cut by my shovel. Remember I said the poly hose is magically attractive to your shovel? I could easily see where the spray was no longer reaching to certain plants very quickly and not having to dig around if it were inline tubing with a break. If you decide to ever use micro irrigation, make sure you reduce the pressure. There are various brands out there, so they may look a little different than the picture here, but they have to lower the pressure on all micro irrigation because the typical pressure coming in from your home, whether it's a well, municipal, or reclaimed, is way too high for those small emitters. It can pop them off and do other funky things that you don't want to have to deal with. Typically the pounds per square inch for micro irrigation is under 20 pounds per inch. That can vary a little bit though. Also, filtration is very important, especially if you are not getting it from a municipal source, from your city, if it's on well, or is coming out of a pond, for example. In some cases we see that here in Pasco County where they're coming out of a pond, and you will get all sorts of little bits coming in to your micro irrigation system and wreaking havoc and clogging it up very quickly. There are different filtration systems. Some are as simple as a very fine mesh screen, some are disc, there are various other types out there. But what is a filter designed to do? Think about that a moment. Seems like a simple question. What's a filter designed to do? Yes, grab the particles, but eventually filters clog up. So they do need attention. They need to be cleaned out or in some cases replaced per the manufacturer or conditions of the water that you're dealing with. This concludes part 1 of owning and operating an irrigation system. So stay tuned for part 2.